start with a new chapter, rigid body dynamics, also known as rotational motion. First of all, what is a rigid body? A body which has a fixed shape, size, and geometry is known as rigid body. But to analyze the motion of a rigid body, we have a better definition. We can say that if this body is a rigid, then the distance between the pair of points will always be fixed. Or we can say that these are the 2 points. This distance will remain unchanged during the course of its motion or during the application of force. So this R is fixed. What is so special about this definition? If we are saying that the distance between them is fixed and this body is performing a motion, then can this particle have velocity with respect to A? Can it have, or when observed from A, this particle B will always be at rest? Let's analyze that. So suppose this is an observer at A, and for him this is at rest, and this is a point B having velocity with respect to A. This is a point B having velocity with respect to A, and this distance is fixed. Now we see that it can have a component along this direction. It can have a component along this direction, and this will increase this distance. Or if it's in some other direction, it may decrease also this distance. So if R is not fixed, then this is not a rigid body. So we say that the velocity of B with respect to A will be either 0 or it will be perpendicular to this line. What I mean by that is, during the motion of a rigid body, this point will have velocity direction perpendicular to line joining them. So what kind of a motion B perform with respect to A, or when observed from A, the B will always be performing circular motion, because this is a property of circular motion. The distance between the object and observer is fixed and the velocity is always perpendicular. So the inference we draw from this definition is that during the motion of a body, a rigid body, the 2 particles on the rigid body will not have velocity of separation or velocity of approach. That means they will not have any relative velocity along the line joining them. Along the line perpendicular to the line joining them, they can have velocity or they may be at rest. For example, so if the point on a rigid body is having velocity always perpendicular to the line joining them, we can say that B perform circular motion with respect to A. That means we can also find the angular speed at this moment. Angular speed is V perpendicular upon R, or VBA upon R. So from ground frame, what we will observe? From ground frame we will observe that along this line, velocity of A and velocity of B will be same, or relative velocity of B with respect to A will be 0. So the B will performing circular motion. To elaborate on this, suppose we have a rigid body and the 2 particles are having the motion such that the velocity of A is in this direction and velocity of B in this direction, and the distance between them is r. So we can say that if we analyze the motion, the component of the velocity will be, along this will be Va cos alpha, along this will be Vb sin alpha, and this point B has velocity along this Vb sin alpha, and along this is Vb cos alpha. We know that this r is fixed. The distance between the particle is fixed because this is a rigid body. That means there should be no relative velocity along this line, or the velocity of separation and velocity of approach will be zero, or we can say that this velocity will be equal to this velocity. So we can say that Va cos alpha is equal to Vb, sorry, this angle is beta, so this is beta, this is also beta, Vb sin beta. This is our first equation. So we know that there is no relative velocity along this line. So this is having relative velocity only perpendicular to this line. So with respect to A, if we draw, this is at rest and this is having velocity Vb, right? And this r is fixed. Can we find this velocity of B with respect to it? Velocity of B minus velocity of A. Add this opposite of this velocity in this. So we will get Vb sin beta plus Va sin alpha. If somebody asks that if it is performing circular motion, find the angular speed. Can we find the angular speed? Yes, the angular speed will be Vba upon Rba, and it will be Vb sin alpha plus Va sin alpha, Vb sin beta plus Va sin alpha upon R. This is the angular velocity of the body. The interesting thing about the rigid body is that this angular velocity will be same between any pair of the point, or by any chance it happens to be the angular speed, then we can say that the angular speed of the body is same. Can we prove this? Yes. On a rigid body, we know that the angular speed between any pair of points is omega. The same will be the angular speed of any other point, or it will be the same as we can say that angular speed of the body. Let's prove this. Suppose between this point the angular velocity is different, omega 1, and between this point the angular velocity is omega 2. But we know that AB distance is fixed. Similarly, BC is also fixed, AC is also fixed. So this is a definite triangle. So we can say that this angle is theta, and theta will also be fixed. What is omega 1? Omega 1 is the rate at which theta is decreasing, and omega 2 is the rate at which the angle is increasing. So we can say that during the motion of the time interval t, we can say that this angle increase as omega 2 t, and this angle decrease is omega 1 t, and this will be the net angle theta, isn't it? Because due to this angular speed the angle is increasing, and due to this angular speed the angle is decreasing. So finally, if we have to write this angle theta, we can write this as omega 2 into t minus omega 1 into t. Now if we differentiate with respect to time, what do we get? We will get omega 2 minus omega 1 is equal to d theta by dt. But since it is a rigid body, Theta is fixed. If theta is constant, we can say that d theta by dt is 0. This is 0. So this value will be 0. So finally we have omega 2 is equal to omega 1. Similarly, at any given instant of time, angular acceleration of a rigid body will be same for all the points. Good. Let's take a simple question. A rod is performing a general motion. One end is having velocity 2 meters per second and other is having velocity 8 meters per second perpendicular to length. The question says we have to find the velocity of the center of mass. Find velocity of center of mass. The rod is uniform, so center of mass will be in the middle. So if we analyze with respect to this point, if we name it as a A and this is B, with respect to this point, the B perform circular motion, and with respect to this point, center of mass also perform circular motion. So if we find the angular speed, let's find the angular speed of the rod. It will be the same for B with respect to A or center of mass with respect to A. So with respect to A, it is having velocity VBA 8 minus 2 6 meter per second, and this distance is 3 meter. So we are getting angular speed as 6 by 3 2 radian per second. Right. Now with respect to A, the center of mass is also performing circular motion. So we can write as velocity of C with respect to A is equal to omega into RCA. V is equal to R omega, and this omega will be the same here because this is a rigid body. And what is this distance? This distance, center of mass distance from A is half, 3 by 2. So this is 3 meter per second. But we have to find velocity of center of mass. If nothing is mentioned, the velocity will be in ground frame. So let us write it. Velocity of C with respect to A is equal to velocity of C minus velocity of A is equal to 3. Velocity of C minus velocity of A is 2 is equal to 3 meter per second. Finally, VC is equal to 3 plus 2, 5 meter per second. So by using the properties of a rigid body, we can easily analyze the motion of a rigid body. We can find the angular speed, and also we can find the velocity of the points. Next is moment of inertia. But before talking moment of inertia, we will see the types of motion a rigid body will perform, like pure rotation, pure translation. Thank you.